So yesterday we talked about what makes a circle a circle. So, Candy, to someone who can tell me the real, true definition of what a circle is. I've got a couple of willing victims here.
There's a shape.
Okay, you're already wrong. Yes?
A segment of a line.
Nope, it's not a segment.
180.
No.
It's a point. It's a ring of points.
You're closer. That's very closer. It is a bunch of points, so we'll start with that. So a set of points. Okay, what makes them ring-shaped? Yes.
Set of points that add up to the intersection.
No, they don't add up to 100 and anything.
A set of points that are equidistant
They're equidistant
It is a shape.
from a dot, from a point.
from which point?
Center.
From the center. Okay? And that's what makes a circle be only a ring instead of a disc. Is because it's only those points that are equidistant. But I didn't tell you an important asterisk, fine print that goes with this. It's the set of points in a single plane, on a flat surface. Because that's just all the points on this surface, but you know, if this was 5 centimeters, what if I went 5 centimeters straight up? Is that on the circle?
No.
No. What is it on?
A different plane.
Uh-huh.
Multiple planes.
It would be on a sphere.
Oh.
A sphere is a set of all points in 3D space from the same center point. So there's a point floating in the center of this ball that you can't see. And everything on the surface is always the same radial distance from that point in the middle.
Volleyball with pool.
Well, you know, it's a 50-cent beach ball from Amazon.com.
What's 40 then?
You should look it up. 4D ones are crazy, but it's still all points equidistant from a single point in 4-dimensional space. Okay? And you can go as many dimensions as you want, and you can do the math on it. There is actual math you can do on that.
I want to eat.
Okay? It's crazy. Okay?
I saw a guy explain that.
So you've got your circle here. How do you name a circle?
The letter?
Call it Bill?
Sure.
You could, but let's be a little more formally mathematical.
The letter in the center.
Whatever you decide to put as the name of the center point becomes the name of your circle. So what should we call this center point?
Bill.
That man.
D.
I heard D. So let's go with D. So that you name it using the letter of the center point. And so this would be circle D. And you can use the little circle symbol, just like you have a little symbol for a triangle. You got your little creepy eyeball there.
Creepy.
It's even creepier if you draw eyelashes on it.
Oh,
Do it.
yeah.
I did that in my last class. See?
Let's do it. Let's do it, dude.
Okay? Alright, so here's a fun one. Math is really good at going through other languages and things and stealing all their words and their symbols. So we've gone to Greek and stolen symbols. We've gone to other languages and stolen their words. We've stolen the exclamation mark from English. And then we went to music and said, what can we steal from music?
Treble clef. Chord.
And so we stole a chord from music. What did we use? A chord is more than one note being played at the same time.
Which chord?
Okay? So imagine, like, if you played a violin and there are 4 strings on it, and you played all 4 strings at once.
I've done that.
That would be a chord. It wouldn't sound real great. Shh, hey. But that would be a chord. And so for some reason, someone in math decided, okay, well, what if you had a violin with just 1 string? Or a harp with just 1 string? And you played it. Well, it'd be a really boring chord, wouldn't it?
It'd be a lot easier.
But what it would look like is it would look like a string that's strung from one end to the other like that. So a chord in a circle is just a segment with endpoints on the circle. So it's got its endpoints on the actual circle. Okay? Can you have any pieces sticking out to the outside? Nope, because the end point is at the circle. If it doesn't make it all the way across, if you have something like that, is that a chord?
No.
Nope, has to go all the way across. Okay, so that's what a chord is. Now, why they picked that for a single segment when a chord should have more than one note, I don't know. Must have been one of those weird mathematicians who doesn't know anything about music, because most of us do. Okay? And
Tickle me.
well, now what I want you to do is in this circle, see how we've got center D? I want you to draw a chord that goes through that center point. Draw anywhere in the circle you want a chord that goes through the center point. Okay? And so I'm going to take mine and I'm going to start it here and go through that center point and go right up next to that red guy. Okay? Is that a chord? How do I know it's a chord? The end points are on the circle. But it's a special chord because it goes through the center, so what do we call it?
Diameter.
That's your old diameter friend. A chord containing the center. Okay. Now, a diameter, we use it to name that chord, but we also use it to describe the length of that chord. So if I ask you, what is the diameter of the circle, you could say, well, Ms. Serna, are you talking about the chord or the length of the chord? Because I might be asking for how long it is, or I might be asking for the name of it. And so, you know, it means both things. It's one of those words that it's like, means a bunch of crap. It's diameter, okay? So you got that guy. What if I had, my red chord. What if I extended the ends of it out beyond the circle? Is it a chord anymore?
That'll be a second.
Oh, a what?
A secant.
Oh, hold on, wait, no. We got to be positive here. We don't want to call it a secant. That would be so negative.
A tangent.
So it's we just say secant. Okay, this is a secant. So it's kind of like you have the little upside down. So a secant. Okay? A secant is a line that contains a chord. But the secant goes further than a chord does. A secant sticks out outside of the chord in one direction or the other. So here's my orange secant, but it contains the red chord that we were talking about back at the beginning. And that's okay. All right? And then we've got tangent. Oh my gosh, are you having flashbacks?
No.
To our trigonometry unit?
I loved that.
It's
That was
tan.
Remember what tangent was? Who remembers the ratio for a tangent?
Opposite
Opposite over adjacent. SOHCAHTOA, TOA, opposite over adjacent. Okay, that is actually very connected to a tangent in a circle. And when you go to pre-cal, you're going to learn all about how the tangent ratio is connected to the tangent segment of a circle. What the heck is a tangent when you're talking about a circle?
Oh no.
Well, it's something in this picture. Can you guess what it is?
D.
It's not a point D, sorry. D is the center point.
B.
I'll give it a shot, dog.
It's a line, okay? What do you notice about that line?
It only hit that one point.
It only touches the circle in one point. So it intersects, there's an S there, intersects the circle at exactly and only one point. And I'm going to put a little asterisk next to this because there's some fine print involved. Okay? When we use the name tangent, sometimes we are also talking about a tangent segment or a tangent ray. And if you're talking about one of those, you're talking about one that would be a piece of a tangent line. So it might look like this. That would be a tangent ray. It might look like that. That would be a tangent segment. And the way you can tell that these are actually tangent segments or tangent rays is if you extended them further, it would still never touch the circle in more than one point. Okay? So I'm going to draw a bad one that is not a tangent. That would not be a tangent. What's wrong with it?
Because if you extend it,
Went the other
it'll
way.
touch it.
If you extended it the other way, it would touch a second time. And that's bad, so we don't want that guy. Okay? So this point where it touches, where a tangent touches, is really important, isn't it?
Yeah, I get
Because it only does it once. And so it gets its own fancy math name. The point where a tangent touches the circle. What could we call that?
Tangent point.
The tangent point would be great. That's what I voted for. But they decided it didn't sound fancy enough, so the point where it touches the circle is called the point of tangency.
Oh.
Oh. So the point where the tangent intersects the circle is called the point of tangency. Ooh, ah. Why they didn't just call it the tangent point? Some of us just do casually. But its official fancy math name is a point of tangency, and you're very impressed, I can tell.
Did you come up with it, or like someone else?
No, it's been around for hundreds of years, and so that's probably why it's a fancy name. But whoever translated it into English could have made it.
Wait, but how do you vote?
I'm sorry, I can't disclose the secrets of our mathematical code. Okay? So, here's a chance for you to discuss and argue amongst yourselves. What of these names, of any mathematical fancy names, would you give these particular things? Are they diameters? Are they radiuses? Are they secants, tangents, chords? Okay, write down what your answers are.
Good story. Good story.
Are you done, or you haven't got to
AB is the
Well, that was just a ratio of the size. It didn't say the scale factor. Oh, okay. And so I did, diameter. So this is over here, and that's fine. But notice when I came over to do the ratio of that, I went ahead and put over the old. I put the bigger one.
That's gotta be a tangent, right?
Well, here it says the area ratio of JKLN. I didn't count it off, you had it upside down. But you just forgot to hold the clock. Because a lot of people are like, do I put it the order it's written here, or do I do it the overall? So I didn't stop it. I'm finished. Okay, yay. If you want to put both of those, just up by my keyboard. Perfect, thank you so much. You're welcome.
Do you need my answer sheet?
Yeah, just stick that to the back. All right, so victims for candy.
I got it.
Someone tell me what you decided to mean AC. Let's see, what you got?
Radius.
That's a radius. Okay. And then let's see, AB is going to be, Sean?
Circumference.
Nope. Yes, Camila? That's a diameter. It is a chord. How can you tell, well, put your hands down for a second. How can you tell that this is really a diameter going through the center?
Because it's not a dot, it's on the center.
See how I highlighted that center dot? Okay? If I just draw something going like that and you're not sure it's a diameter, if I haven't highlighted a dot in the center, don't consider it a diameter. The way you can tell is if I put that center point there and it looks like a Pokeball, then you know you're good. Okay, so now AG is going to go from here to G, so what part did you call that?
Chord.
That's chord.
Whoa.
Which looks like chord, but it's chord.
Say chord.
And then Ray, D-E, starts at D and comes down here. Okay, yes. It's a tangent, and specifically, it's a tangent ray. Okay? I will accept tangent because mathematicians get lazy about it. You know what we also do here? We say that this ray is tangent to the circle, like it's a verb. Okay? So a tangent is tangent to the circle. It just meets it at one spot. We use it like both a verb and a noun, which is really hard for the people who are trying to learn English anyway. And then we throw in all this extra crap. Okay?
I learned it yesterday.
Yeah, you're learning all those fancy English words. And then we've got A, E, but a whole line. So the whole line, A, E. Yes, sir. That's going to be a secant. Okay. Are you impressed yet?
No.
Probably not. So let's start learning some theorems instead. So get out your green formula chart and find theorem 1. Now on your formula chart, they put some letters on here. What did they name the point of tangency?
Q.
P.
Really? Yeah, they did. No, Q is the center. What did they name the point of tangency?
They didn't name it.
Oh, they did, because the point of tangency is where this tangent line touches the circle.
But they didn't name it.
Oh, they did, on your formula chart,
P.
Yeah.
and they named it P. Is M a point on that line or the name of the line?
Name of the line.
It's the name, you can tell because it's italic.
And it doesn't have a...
And there's no point being highlighted. And so remember back at the very beginning of the year, we said you name lines by using a lowercase italic or cursive letter?
No.
I mean, all this old junk comes back. Okay? And so in this picture, I see something that looks like it might be tangent, and I see, what is QP?
That's a
A radius. And what do you notice about that tangent and that radius?
Makes it right angle.
It appears to be perpendicular, making a right angle. So what this theorem says is that if line M, okay, well, it actually uses if and only if. It tells you that line M is tangent to the circle, and what's going to be the name of this circle?
Q.
Circle Q. If and only if. What's that tell you?
Oh, it's biconditional.
It's biconditional. So it's going to work both ways. So it's tangent if and only if the line M is perpendicular to that radius. So let's see. If it's perpendicular, this has to be a tangent. The other direction says if this is a tangent, it has to be perpendicular. This is all you get on the test, is this. None of the explanation. So you have to know when you look at this that that's what it's telling you. Oh, if I see it's perpendicular, I can say it's a tangent line. If they tell me it's a tangent line, I could say it's perpendicular. Those are the things you have to know just from that. And so what's going to happen is you're going to get a picture like this. And they're going to ask, is ST tangent to circle P?
Plug it into my account.
How would I know? What would give it away that it was tangent? If there was a right angle there. How could I find out if that's really a right angle? I could test it with the Pythagorean theorem. And if it works, we've got ourselves a tangent. If it doesn't work, we don't. So let's test it. What would we plug in? For Candy, someone tell me, what would we plug in? Yes. Nicole.
35 squared,
Mm-hmm.
12 squared equals 37 squared.
Why did I write a 2? I don't know. 37 squared, because yes, we're going with that's the whole thing. And so you have calculators, and so you start typing stuff in. I know 12 squared is 144. How much is 35 squared?
1225.
1225, thank you. And how much was 37 squared?
13.
1369. So someone type this sum in. Does it equal 1369?
Yes.
Okay, since they're equal, what do I know?
The right angle.
It's a right triangle. Since it's a right triangle, what do I know?
Yeah, right angle.
That these are perpendicular. Since they're perpendicular, what do I know about ST?
Tangent.
It's tangent. That's the thought process of it. That's technically how you would do the proof of it. But you don't have to do a proof. All you have to do is know all that so that you can answer, yes, it's a tangent. And so sometimes it'll say tangent of, sometimes it will say tangent to, and we're talking about the same thing. Turn the page. Now this one's using the converse. Now I tell you, it has a point of tangency. Well, if I have a point of tangency, what is AB? No. No.
Say a segment.
It's what kind of segment? A tangent segment. If you have a point of tangency, you must have something being tangent there. Okay? Well, if it's tangent, what do I know about where that tangent meets this radius?
It's right angle.
It must be right angle. Can I use that fact now to find R?
Yes.
What formula should I use?
Pythagorean theorem.
See, those triangles keep showing up in our circles. Can't get away from them. So, okay, what would I plug into my formula then? You've already answered one. New victim. 80 squared plus R squared would equal,
50 plus R.
yeah, I need the whole hypotenuse, which would be 50 plus R. And then squared. Uh-oh, now you have to know how to square a binomial from algebra last year. Can you stop doing that, please? Thank you. Because I know this is 6,400, and I know this is R squared. What will this be, 50 squared plus R squared?
50 R squared.
Nope.
You do.
No, it's 50 R plus.
You'll have to do 50 plus R times 50 plus R, which is going to be what, 2,500 plus 50R plus 50 more R, so 100 Rs, and then plus R squared?
Yep.
You're like, dang it, I don't want to remember that stuff, too bad. And so should we combine like terms?
Yeah.
So let's see, let's move these R squareds. Oh, look! These R squares canceled over here, but look, they cancel over there too.
Wow.
And then let's move our 2,500 over here. That's going to be what, 3,900 equals 100 R? Divide by 100,
39.
and R is 39. And you would be half right!
39.
R equals 39.
R is a radius, it would have a length, and you'd put feet. You're geniuses. Okay, theorem 2. So look at your theorem 2 on your formula chart. And here's theorem 2 here. What do you think theorem 2 is about? Just looking at the picture.
Probably about tangents.
About tangents. Because don't these kind of look like they're touching the circle in only one point?
Tangent.
And what do you notice about these two tangents?
There's two lines.
They're touching each other outside the circle. And then what's on mine that isn't on your formula chart?
Lines.
These little congruent lines. Okay? And so, but you've got letters. You've got R and T, and this one's S,
P is the middle.
and P is our midpoint?
The middle.
Center.
Center. The center of the circle. It's not called the middle, it's called the center. Give it its proper name. The center would be the midpoint of the diameter. There you go. If it makes you happier. Okay? So, what this theorem says is if RS and ST are actually tangents. Okay? If they really are, and in this case it's talking about tangent segments.
God bless you.
Okay? So if they are tangent segments, it tells you that this outside piece has to equal that one. They have to be congruent. RS is congruent to ST. What if they aren't tangents?
And they're not congruent.
They're not congruent. Inside, look, it's like a little party hat. See, you put a little smiley face on him. He's got a little party hat on. Or you could turn it upside down this way and make it be like an ice cream cone.
It's thrown out, it looks like chopsticks holding food.
Or it could be holding some sushi. Yeah.
Oh, yeah.
I'm hungry now. Okay? So, when will this theorem be useful?
Yeah.
When you see a picture like this one. Shh. What does it tell me in the instructions? RS is a tangent. So this guy is tangent right here at that point. What else do we know?
C is the center.
C is the center because they named it after C. Keep reading. What else do we got?
RT is tangent.
RT is also tangent. Now, if you weren't sure what to do with this, you would look at your formula chart and try and find a picture that kind of looks like it and see if it tells you anything. And when you look at it, what does it tell you happens when you have two tangents? The parts outside are congruent. So you could say 3x plus 4 would have to equal
No congruent.
28. Well, if congruency implies equal lengths. Oh dear, I hope you can solve something that incredibly complicated all on your very own.
Literally, how she doing that?
That's too hard for me.
Okay? And x would be 8. Is it helpful to have the formula chart in case you couldn't remember quite what to do?
Yeah.
Be grateful, last year you had to memorize it all. You just had to know in your head, oh, if I see two tangents, those two things, if they touch, they're congruent. You just had to know that. I know, crazy. So let's make it uglier. Turn your formula chart over to theorem 14. And now we're going to be, since we've been doing segments, let's just stick with stuff that has segments. What kinds of segments are these guys? What are these guys called? They're chords. So if I have chords what are my chords doing inside my circle?
Intersecting.
They're intersecting. So if you have segments of chords intersecting inside the circle, it tells you just a relationship. I've got this red chord and I've got this green chord. Okay? What are the two parts of my red chord?
EA.
I've got EA and I've got EB. Those are the two pieces. And I'm going to leave the segment bar off of them so I can be thinking about how long they are. Okay? What about my green chord? What are the two links on my green chord? EC and ED. Okay? And so this is a part of the red, and this is part of the red, and this is part of the green, and this is part of the green. And what this theorem tells you is that when you have two intersecting chords, if you multiply the two parts of one guy, it should equal what you get when you multiply the two parts of the other guy. Because they're proportional. This is what you get after cross-multiplying some fancy proportion that you would hate. Okay? Part times part equals part times part. See? Part times part equals part times part. Part. It almost sounds like arc. We just keep bringing those seals in here, huh? We have a zoo going on. But alas, I'm not allowed to have a pet in the classroom.
Please don't raise it. I'm terrified.
I'm not allowed to have a class pet. So, all right, shh.
Why did they let Ella raise?
So, in this example, What objects do you see in this picture? Chords. And what are they doing? They're intersecting. So I'm allowed to say that the 2 parts of one multiplied should equal the 2 parts of the other multiplied. So what are my 2 parts of my green chord that I can multiply? Go ahead, Jack.
X plus 2
Times.
times X plus 1.
Okay. And what should that equal when somebody else gets to suffer? Nope, you've already suffered enough. You've suffered. Who haven't I picked on yet? Natalia. I haven't picked on you yet. So the green guys multiplied together. What should I multiply together that equals them? And just times a plain old X. These 2 parts multiplied equal these 2 parts multiplied. Oh, look, you get to multiply stuff again. So go ahead and be working that out. Figure out what you get when you multiply these. Remember, you get to double distribute these guys, and you get to just single distribute that guy. You miss doing algebra so much.
I do.
It doesn't equal each other. Oh my God.
What?
She just called herself.
What's that? I'm sorry, I didn't hear.
Called someone dumb.
Oh, I said it was myself.
Well, we don't call people in my class that, not even ourselves.
Oh,
Dare you.
my bad.
Yeah, see, because you're a person too.
I am.
So this will be what? X squared plus 4x on the red side, and x squared plus 3x plus 2 on the green side. And then, oh look, I can take an x squared off of each side, can't I?
Yep. Yeah.
And then I can subtract the 3x over here, and 2 equals x?
4x.
Oh no, because I subtracted 3x from both sides.
Equals 2.
I wrote my work down. And this would not get you points.
Nope.
This would get you 1 point out of 5.
You gotta find an ML.
Oh, you gotta put in the...
Because it specifically says actually, now, this is a typo. If I'm asking for links, should I have segment bars on top? No. I should just be asking for ML. So for ML, I would need to add up x plus 4 and x. Well, x is 2. What's x plus 4?
6.
So how much is ML?
8.
8. And then JK
7.
is going to be 4 and 3, which is 7. That would get you all your points.
Literally all 5?
All 5. That would be a 5-point problem on a test, and that's how I would break up the points. What? Come on!
You got the eraser right there.
Okay.
Literally, dude.
Now we got to turn it and do the really bad stuff.
Some fast reaction.
Less hard. Less hard than I thought.
Too late. The God's heard you already.
Sorry, God.
No, not God. We don't have God. We just have the math gods.
Plural.
Lowercase g.
Just say God.
I don't believe in
Okay.
God.
Okay, so, guys, you've learned about segments. You've learned about secants. What do you think a secant segment is?
It's a segment that's in a secant that can't see. Wow. That's a good one. You gotta
The two combined.
Well, what do you think a combination of a secant and a segment would, how would you describe that?
A secant segment?
That's the name. How would you describe it?
Just like that.
It's a segment. Uh-huh. Well, so how would you describe what it looks like?
It's a secant.
Like that.
Which one?
Looks like a secant.
Is the top one, do you think, a secant segment? No, that's a tangent segment. Because it only touches in one place. So a secant segment is a segment that contains a chord. And it touches in 2 places, right?
Yep.
And, so here, one of its endpoints is the endpoint of the chord. But the other endpoint, it contains the chord, but the other endpoint is outside the circle. Okay, so that would be a secant segment. Would this be a secant segment?
What?
No. I can't see.
Nope.
No.
Yes.
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 I hear yes and no.
Yes.
Literally
Give
no.
the points up.
Does it contain a chord?
Yes.
Is one of its endpoints outside the circle?
Yes.
Would this be a secant segment?
I'm gonna go with yes.
No.
With our-
No. Because it doesn't contain a chord. It contains just a radius. Okay? So that would be bad. That one wouldn't be allowed. Okay? Now, when you have a secant segment, see how it's got actually two parts? It's got an inside part and an outside part. See how that works? We already have a name for the inside part of a secant segment. What's this inside part called? That's called a chord. What's the outside part called? Nope.
Tangent.
It's not a tangent because if this does,
segment.
it's the external part. So external. So it's the external secant segment. It's the part of the secant segment outside the circle. So the whole thing is called the secant segment, and the outside part is called the external secant segment. That's not confusing at all.
Literally no.
Literally.
Okay? So now look on your formula chart at theorem 15. It should have a picture that looks kind of like this. What do you see in this picture?
A secant.
A secant? Nope.
Segment. Two secants.
Not even two secants.
Triangle.
Two secant
Of segments.
segments. No, you just said secant.
I said two secants.
You didn't say the segment's loud enough for me to hear. I'm sorry. Okay? And what do you notice about those secant segments?
They intersect.
They intersect. Okay? Because if you had parallel ones, what we're about to do wouldn't work. So this would not work. They have to touch outside the circle. Okay? And all it tells you is EA, which is that guy, times EB, which is this guy, and that it equals EC times ED, which is this guy. I need someone to describe what these different parts are. What is EA?
That is.
External.
It's the external part. Do you mind if I call it just the outside?
Sure.
The outside part?
Doesn't bother.
Okay. And what is EB?
That is a chord.
Really?
No, that's
the
segment chord.
It's the whole secant segment, isn't it, from E to B? So that's your whole thing. So you've got the outside part and the whole secant segment. Did we do anything with the chord part? Nope. And then what's EC?
External.
It's another outside part, an external secant segment. And then what's ED?
Secant segment.
The whole thing. So what this theorem is telling you, if you got to this problem on your test, and you weren't sure what to do, and so you went and found this picture, are the letters the same?
No.
No. So you would have to know what the letters mean. And you'd have to know that EA is talking about the outside part of a secant segment. Okay? Well, what's one of those in this picture? What's an outside part here? GH, which is how long?
3.
3. And I can multiply it by the whole secant segment that it's on.
7.
What's my whole thing?
7.
It's 7. See how you have to be able to interpret what the formula chart is saying?
Yeah.
And so then, I would need another outside part. So what's another outside part I could use? JH, which is 2. And then I'd need a whole thing, which is how much?
T plus X.
Is it 2 times x or 2 plus x?
2 times it.
Wait, 2 plus
Plus.
X.
Times.
The whole length, you just add the parts, right? Segment addition?
Yeah.
So it'd be x plus 2. So that formula is telling you can do the outside times the whole should equal the outside times the whole of 2 different intersecting secant segments. But all you're going to see on your formula chart is this little guy. And so you have to understand what it means for it to be helpful to you. Okay? Oh, y'all can solve that, can't you?
No.
Really? You don't know 3 times 7? That's a big oof. That's 21. And then Sebastian, what's 2 times x plus 2?
2x plus 4.
Plus the 4, thank you. And so you minus the 4 from both sides, and 2x equals 17,
Oh, crap.
which means x is 17 halves.
Could you?
Yes, right.
Yeah, you could leave it like that. What else could you write? 8.5? Or 8.5? Okay? Does it help to have this to look back on to help you know how to set it up?
Yes.
Yes, so you don't have to, but you have to understand what it's telling you. Okay, and then there's one more we're going to do. Theorem 16. Theorem 16 is actually exactly the same as Theorem 15.
What?
It doesn't look the same, but it's actually the same thing.
Why is it 2 different things?
Okay, look at the picture. What looks different about the picture?
This is tangent.
This one's a tangent segment, and what's this one down here?
A secant.
A secant segment, okay? Okay, and so they look a little bit different, but it actually works the same way. So play along with me here, okay? What would be the outside part of this green guy?
EC.
It'd be EC, okay? What would be the whole secant segment?
ED.
ED. That's the same thing we did with the secant up here, isn't it?
Yeah, please.
Okay. Now for this tangent guy, I'm going to treat it like a secant. So let's look for what's its outside part.
EA.
It's EA. How much is my whole tangent?
EA.
EA. So I can still do outside times whole and outside times whole. But what happens when your outside and your whole thing are the same?
Just square.
If you just square it, and so it says EA squared equals EC. Well, I said EC and I wrote CD. What the heck? EC times ED. So as long as they intersect outside the circle, it's basically the same formula. Outside whole, outside whole. So looking at this feller down here, Candy, to someone who can tell me how to set, someone who hasn't already received any today, how would you set this one up using this formula? Abraham?
X,
So that's my outside part.
plus, X plus 8.
It's actually times x plus 8. I'm sure you thought times, but your mouth said plus. Okay?
And that equals 16 squared.
Yeah. And you could either decide it's 16 times 16 or just write 16 squared. And so you'd go, great, I can do this. X times x is x squared. X times 8 is 8x equals 256. Uh-oh. It's a
number.
If I want to solve this, what am I going to have to make it equal?
0.
0. So I'm going to have to do x squared plus 8x minus 256 equals 0. And guess what? You could factor it, but it doesn't factor into pretty whole numbers.
Oh, x equals negative 8 squared.
Which means you might have to go back to this step and do the completing the square thing. You're allowed to do that.
I don't remember that.
Well, if you don't remember it, don't do it. Do something you do remember, which is,
Quadratic formula.
okay, who wants candy to, by singing the quadratic formula to me? Okay, if whoever wants to sing it, you can get candy.
X equals negative b plus or minus the square root of b squared minus 4ac all over 2a.
Okay, so go get your candy, that's what you would do, I'm not going to do it, start your homework.
I got
Oh, yeah. Much welcome.